Hello, everybody. Welcome to our RagHack live streams.
RagHack is a free global hackathon happening from September 3rd to 16th. RAG is a technique to get a large language model to answer questions based off your data. We have more than 25 live streams teaching you how to build RAG apps with different Microsoft technologies, plus 10 cash prizes for the best RAG apps in each category. So we're super excited to have you join us for this RagHack. And now a word from our friends at Reactor.
Hey everyone, thanks for joining us for the next session of our RAG hack, Internationalization for RAG. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer. Our session is being recorded. It will be available to view on demand on the Microsoft Reactor YouTube channel. With that, I'd love to turn it over to our presenters. Thanks so much for joining us today.
All right. I think we're live. Okay, great. Hey, everybody.
Hi.
I'm Anthony. And this is Renee.
Hello. Excited to be
Hey.
here.
So it's an international session today. We've got, I'm from Sydney and Renee is also from Sydney. So we've gone full globe. We've got people on here from Redmond in the US as well. On our team, we've got people from Europe and from Asia as well on the chat. And today we're going to talk about internationalization, which is an extremely difficult word to say in RAG apps. And I'm going to give you a rundown of large language models and how they deal with other languages, and I say other languages than English. And we're going to kind of pick apart, I guess, how the technology handles different languages and how you need to think about some of the techniques that you would have learned about in the RAG, things like chunking, splitting, query rewriting, translation, search, or just generally working with text and data. So in particular, I'm going to demo a few things in Japanese, in Japan. I'm going to demo things in Japanese because that is the only language that I understand other than English. And my Japanese understanding is still pretty small. I'll see in the chat, we've got one person. Oh, hi, Ben, from Japan as well, joining us. I know Ben's Japanese is a lot better than mine. So hopefully you can correct any of my mistakes later on. So for RAG and for LLMs in general, a large language model, I guess one massive component is that it's a understanding of language. And it's done that because the model is so large, it's seen so much information and so much written text that it can kind of reproduce or understand, I guess, in like high level terms, different bits of language. Now, how the LLM actually works is that it doesn't look at words or text, it looks at tokens. And this distinction is kind of the foundation for understanding embeddings, understanding splitting, understanding RAG, is recognizing that an LLM looks at tokens as numbers. It does not look at words or sentences. It doesn't really actually see those words at all. It just has in its model all the numbers that it represents. And we're going to talk about GPT 3.5 and GPT 4 because they have the same tokenization model. So on the OpenAI website, you can go to Tokenizer and you can type in a sentence like this.
Anthony, should you have your screen shared at this time?
I was.
Fantastic.
Is it?
There we go.
Got it? Okay.
That is currently, there we go. That's much better.
Okay, so if I type in a sentence, hello, this is Anthony. then that is represented by these tokens. And there are 6 tokens, and it splits the text up into pieces. And what it sends the GPT, when we do a chat completion, when we do an embedding, we send these tokens rather than the words. And if you look at the numbers, each word is represented by a number. So hello is a really, really common word that appears in a lot of text. A comma is very common. And then you'll see that the tokens are also split up with a space and then the word. So this and is and my name are all super common tokens. So they have a space in the token database. The encoding model for GPT-3.5 and GPT-4 is called CL100K base. The 100K basically means that there are 100,000 different tokens in the database. So if, for example, I spelt my name slightly differently, like you'd get a different number. So that number changes for the 2 different spellings of my name. This is like super efficient and a great way to encode English text. And it's based on how frequently it saw certain words or bits of words in text. So for example, if I was to misspell my name and put 2 N's in there, it would break it up because Anthony with 2 N's, it probably hasn't seen that before. So instead it turns that into 3 tokens, the AN, the THON, and then the NY. So a general rule of thumb we have is that you can kind of roughly divide the number of words that you've got in a sentence by 2, and that's more or less like how many tokens you'd expect to see. Now, this is great. So if I actually just copy and paste that paragraph above and stick it in here, you'll see like how it tokenizes that information is pretty efficient. Like its tokenization is just 2 tokens. A lot of these are a single word. Now, where this efficiency starts to drop is when you start looking at other languages. And that's kind of the basis of what I want to cover today is, it's a large language model. It understands and can talk in other languages. It's really good at translating from English into other languages and vice versa. But there are differences. And there are assumptions that people make when they're building RAG applications or AI applications in general, based on what they experience in English and then what they see in other languages. So if I type a sentence, I do the same sentence in English and then actually, Australia is extremely difficult to write in Japanese. I'm not going to do that. I'm going to say hello from Japan, and then just switch my keyboard. If you just write hello, that is a common word. So hello in Japanese is super common. That has its own token. Japan probably like that one is then split up into different tokens. So you'll see here I've got a comma. That, if you look really closely, that's not actually a normal comma. That's not the ASCII comma. It's a different type of comma. Then it split up the word, it split up the word Japan into 2 different tokens, and then is des, this is the last one, is a single token. If I do the word for cat, this is an interesting one. Where'd it go? You'll see things then start to go a bit wild and a bit wrong. There's even a warning the developers have added for you because people have started noticing this. So that is the character for cat. And you'll see that that is actually now 3 tokens. So a single word, the word for cat, if I wrote that in English, that is a single token. In Japanese, that is 3. So you might be wondering, is it doing it by like the parts of the kanji? So like, is it splitting up by that? It's not at all. It's just looking at the Unicode value and then looking up in the database to resolve where it is. So what I've discovered is that if you have a sentence in English, you translate it to another language, and then you work out how many tokens it is. In general, other languages have more tokens per word than English. And this is important because when you're working with RAG, when you prepare the data, you have to split it up. And I've seen time and time again, people make the assumption that the ratio of words to tokens is roughly whatever it was on the GPT website. So what you'll see is that because the model is trained more on English than any other language, the token efficiency, I guess you want to call it that, is much better with English than it is for any other language. French, German, Italian, Portuguese, and Spanish have a lot of similarities. They all roughly use the same alphabet as English. So you only get like 45% to 32% more tokens for those words than you would for English. But then things are really different when you look at something with more sort of complicated scripts like Korean, Japanese, and then the two Chinese dialects as well, where you'd actually see twice as many tokens for the same sentence. Probably one of the worst, least efficient languages I've looked at was Hindi, which I think is about 4 times the number of tokens to words that you would get. So you might be wondering, why does that matter? Well, when you're working with models, you normally have a limit on the number of tokens that you can input. So if you're working with an embedding model or a chat completion model, you would have a limit on the number of tokens that you can enter. And the way that we do this in RAG is that we break documents or text up into smaller pieces, smaller chunks. So the first thing I want to cover in this session today is about chunking and splitting. So when you're doing RAG preparation and you've got text or documents which are not in English, you have to do a few different things. And I've got this notebook which we'll share later, which has kind of got some of the code and the examples in it. So this is a bit of text. There is no way that this would fit into the context window for probably any of the models. If I stick it in here and look to see, that's 31 tokens for 28 characters. Some of those tokens, that's Shin, that's just new, but that's an easy one. But some of these, like this one here, that's, I don't even know what that means. Listening, I think. That's 2. Some of these are like 3. Like it basically has a lot of tokens to represent that data. So if we do splitting or chunking, I'll show you, like, this is the most common technique that I see in people's projects or in their code, and it would be to use a recursive text splitter. A recursive text splitter, you ask it for the size of the chunk. So let's say you need to break, to put it into an index like a vector database, or to take bits of a document and then to chunk them in order for context. You would need to split them up into pieces. LangChain has what's called a recursive splitter. A recursive splitter essentially looks at the text that you've provided. So this is a snippet of a book called Memories of Mars, which is an open text, so you can copy and paste it and use it for testing. It's in the Gutenberg project, so you can download the plain text and you can use it for testing. It's a really nice testing tool. If I give this snippet is actually from the LangChain website, and this is like their introduction to chunking. So I've copied their introduction to chunking, and in this they used for the text a State of the Union address, which is in English because it's American, presented the American government. And they use that to split it up into chunks that should be about 250 characters. And the reason you'd use the characters is because roughly, like when you were working with English, you could use their rule of thumb that a token is roughly 3/4 of a word. So 100 tokens is roughly 75 words. So I've used this as an example to take this bit of text to split it by characters. The recursive splitter will look for boundaries in the text, like as a paragraph break or a full stop, or it will also look for commas or line breaks as a kind of a natural place where the text would stop. And then the last thing it would look for is like spaces between words. So it won't split a sentence halfway in the, like in the middle of a word. It will look for spaces between the words. So if I use this like LangChain example and give it this book, I've asked for chunks of 250, and I'm going to print out the length of the chunk, like the number of characters, and then the length of the encoding. So like how many tokens is it? And so it's given me that if I look at the first two chunks, the first one is 143 characters and 149 tokens. And then the second one is 159 characters and 170 tokens, which is miles off what I asked for. So I asked for a chunk size of 250. And if you did that with the state of the union address, which is in the LangChain examples, like it really nicely finds a paragraph boundary or a sentence boundary and says, oh, this is like the closest point I could find. When you're working with Korean, Japanese, Thai, Arabic, there's a couple of others as well, there are no spaces between the words. And also the like that full stop is a special Unicode character. That comma is a special Unicode character, and by default, LangChain is not looking for those. So all it's actually doing is it's splitting by. There happens to be like a paragraph break here somewhere. I think it's probably this one, like in the new line break. It uses that because it can't find anything else. So if you just use LangChain out of the box and say, can you chunk this document up for me, and it's not in English, it will give you chunks which are too big or too small. So that's kind of my example of if you just take probably what the documentation says for you to do, your result is not going to perform very well. The chunks are going to be way too small, and your retrieval in RAG is not going to be very good. So we can improve on that slightly by in LangChain, you can actually say, okay, don't look for just the normal separators like the ASCII, like comma and the full stop, but like here's some extra ones. There's like full width characters. This is not an exhaustive list, but this is kind of my recommendation for Chinese, Japanese, and Korean in particular. So is to look for these additional separators in the text. If we do that and then we ask again for a recursive splitter, but we've got a better list of separators, you'll see that the text length chunks are closer to 250. So that's a better one because this sample is actually split it up and it's found like some paragraph, like a sentence boundary, which is this full stop here. And it's used that because it's closer to the 250 mark. And it knows that now because I've given it a list of unusual like characters that are used to separate sentences. And it can't rely on spaces for these scripts. When you're dealing with more sort of Western European languages, the Spanish, Italian, Portuguese, you don't necessarily have this issue because they use ASCII full stops and commas and they have spaces between words. But definitely when you work with languages which aren't based on the Latin alphabet, you need to really kind of look at how it's splitting the text. However, there's a big flaw in this one, which is it's looking for a chunk size of 250, and that's 250 characters. And this is another mistake people make, is that they kind of use this sample and say, okay, great, we've got 250 characters, and they give it to the AI, and then the AI spits out an error because the second chunk is 233 characters, but it's 262 tokens. And LangChain is actually counting the number of characters on the assumption that the number of tokens is less than that. and because we're working with Japanese, in some cases the number of tokens is actually more, because as we saw with like the word for cat, that single character is 3 tokens. So like on average, we're going to have more tokens per piece of text. There's a question in the chat, are there any rough ratios or so regarding the difference for different languages? I've worked out, like, I've got a longer list for this ratio, but I don't recommend kind of hard coding in any of these numbers because they can vary massively. And kind of so Chinese, for example, like, there are like 10,000 different characters, and depending on what the text is about and which characters they're using in the text, it can vary massively between one point. If you look at the range here, like that's the average, but the outliers are like 5 times. In Japanese, they go all the way up to 8. And I saw in Hindi in particular, like it went all the way up to 10 times for certain sentences. So like I wouldn't recommend getting around this by putting a different ratio in. What I recommend instead, which is kind of my final example, is that when you use recursive text splitters, you override the length function to actually use an encoding count. So what you can do this in LangChain, there's this method here that you can add on the end of the text splitter that says, instead of using the length of the chunk, the characters, calculate the length by actually encoding the chunk and then counting the number of tokens. So what you'll get is actually an output where the token count is closer to 250 and always within 250. So this sample, I'm saying, okay, use the tick token encoder, which is the OpenAI encoder, and my model is GPT-4. The encoding, it will be the same for 3.5 and GPT-4. It uses the same token encoding. I've got my special separators list, and I want you to get within 250 in the chunks. So like this is how I recommend doing it. There's a blog post about this, so I can share a link to. And then that will give you chunk sizes which are correct and within the range and not wildly too small.
I have a question from Pamela as well on that. Does that work with GPT-4o as well? That uses the new encoder.
This one, so when you specify the model, you need to give it the encoding name. GPT-4o has a different encoding from what I remember, and it has more characters in its database. So yeah, this pattern works the same, but you change the model name to GPT-4o, and then you'd get the same result. So yeah, that's how we would deal with chunking. Now, I then want to move on to a really simple demo app that I've kind of put together for this session, and this is it's a RAG app. It's a store, and I've got a vector database in quotes in behind the scenes to implement search functionality and kind of show how you can introduce some internationalization to a RAG app. So the first thing, I guess, is that all the text on this page is in English. So whilst this is not like this is not RAG specific, but what I've done with the page is I've added some data, like some translation keys to the text, and then I've just added a language switcher. So if I switch to Japanese, then I've got the text in another language. GPT-4 3.5 as well, like is very good at translating when you ask it to specifically translate from one language to another. So if I'm using Copilot here in Visual Studio Code, and I added this translations file where I've got like the things on the page, and then I filled out what they are in English, and then I can type in a language code. so like if I did Korean, for example, then Copilot would populate the results for me. This is fine for testing, but I haven't specifically asked GPT, can you translate the word search into Korean for me? And I think if I did that, I'd probably get slightly more accurate results, especially when it came to longer sentences or descriptions. So like this description here is a pretty long sentence. And yeah, it's a whole paragraph pretty much. And I've asked it to spit out something in Korean. I can't read Korean. I don't know if that's correct. I would not rely on that translation. I would actually copy the description and stick it into GPT-4 and say, can you translate this into Korean for me? And then verify that with somebody who speaks Korean. I'll show you just a site that I use. So this is Crowdin. And this is how I recommend you look at like professional translations. In Crowdin, I use this for VS Code Pets, which supports a lot of different languages. And what you do with Crowdin is you create a bundle, which is all your bits of text, all your words and stuff. Mind.
Apparently our translation is actually quite good, thanks to Sunjin in the chat, as well as our lovely PM, Josh.
Right. Oh, yeah. Josh
translation. So it's going pretty well.
I should have remembered that. If I log into Crowdin. Okay, they've changed their login mechanism. That's
we have
annoying.
A question from about Swedish. So a common pop song in Swedish will have a larger characters/token ratio when compared to translations of earlier works of Heidegger and Nietzsche than compared to more uncommon words in those same languages?
Yes, I would agree to that. If you look at the training set that's used for GPT and also how they got to the encoding model, a lot of it is public web information, and it's not necessarily like works or books or like papers or literature. A good example of that is if you look at the encoding, there's an entire token for one person's YouTube handle, because it saw GPT was trained on so much like Reddit and like YouTube threads that it saw this one person's YouTube handle so many times that is one token. So there's 100,000 tokens in GPT-4, and one of those tokens is just for this one person's YouTube handle. Whereas I showed you like the word for cat in Japanese is 3 tokens. So there is an over bias to like the social media sites that GPT was trained on and the public data sets that it was trained on. So you'll find it varies massively when you look at other types of text, which it probably hasn't seen before. It hasn't seen a lot of before. So yes, that's so yeah, like pop songs and stuff like that, like casual language, it would encode pretty efficiently. What I was saying with the translations is that if you use a site like Crowdin for professional translations, then third parties can review the translations and they can submit or discuss like what's the best way to say something. Because when I did it in here in Copilot, like I didn't specify like what form or which, like a lot of languages have got lots of different ways of saying things. English is the same. There's multiple different ways I could have written like how I used a sentence, my punctuation, my grammar, or just like the forms of certain words. And in other languages as well, you have that. And I was never explicit with the like with the Japanese version, for example, or in the Korean version, like which kind of forms to use and which there's a word for it, but like which versions of the nouns to use. So like how formal should the site be and like how should the grammar work? If you're doing the translations with a third party to review them, it's much better to do that because they can discuss and and actually come back. And what I found with the extension, so with this VS Code Pets, is that there's actually discussion with, like, there's a kind of translation for certain words, and then different native speakers then actually debate within each other, like which one would be the right word to use. So I recommend using something like CrowdIn, because you can, with CrowdIn, you can it can submit pull requests back into your repository, and you've basically got like a resource file with all the translations. So I haven't done that for this one. I've just let Copilot do it for me. I'm not fluent enough to read all of that and verify it, but it looks fine. So it looks fine for a demo. We've got a search page at the top, and what I wanted to add was some search functionality. So this is typical RAG. So we've got our retrieval step, and in the retrieval, we've got typically some sort of search, whether that's to structured or unstructured data. And I've got a list of, let me switch it back to English so everyone can follow along. So I've got a really, really simple database where I actually started off in GPT 4.0 and said, I've got a really simple database. Let me find the prompt again. Actually, let's reset this.
Well, Anthony does that. We've jumped over to the Azure OpenAI Studio. So if you set up your Azure AI endpoints, you can access this to give it a go in the playgrounds. This is also where you set up your deployment. So your choice of GPT 3.5 Turbo 3K, or your Vision one, or your embeddings ones. You can set up all your things, and you can give some things a go in the playground.
Yeah, sorry, Renee. I'm used to just jumping in between tools.
No worries. I figured I'm just here. I don't have a question to prompt you with right now, so I just like, you got stuff to reset. I'll help out.
Yeah. So I asked it, can you create some sample data in JSON for me? This is a data set of products for a clothing store. The attributes to populate are name, description, price, and what else did I ask for? Image, but that one doesn't really matter. And if I did that basically to get like a sample data set, and that gave me some products, and these were some clothes. So like, the names are not very creative. So I think if you increase the spiciness level by raising the temperature, then you're going to get a product that's not just called dress, because my temperature is 0 at the moment. So I did that with this sample data set, and it came up with Azure Dream t-shirt, and it had a description for me. And what I did was then copied and pasted that description into Bing Create and said, can you create a photo of a product with this description? And what I then got is basically like a set of photos of my fictional products in my database. So like, if I search in my shop for t-shirt, I should get back the 2 t-shirts, the eco-friendly one, which is green, that's pretty cool, and then my Azure Dream t-shirt. So I asked Bing Create to make images based on the descriptions, and then I stuck those in my database and have used them for this this RAG sample. So we've got our translations, which Copilot created for me, but we could definitely use a professional tool to kind of manage those. And then I can type in search questions, and it would do a hybrid search on my back end. So the implementation of this is, let me kind of go forward a bit. So I've got in Python, I've got the search query, which is the text that I typed in, and then I'm going to send that to my backend, which is I said it's a vector database. I kind of lied. It's not. It's SQLite. And what I'm doing is basically taking this JSON, putting it in a SQLite database, and then I can query it. I've got, you'll see here, so when you do similarity search, you need the embeddings, and I've got the embeddings for the name plus the description. So I did that by writing a really simple bit of Python code to go through the test.json file to see if I had populated the embeddings yet. And if I hadn't, and I'm going to go and fetch them by using the embeddings API, and then creating the embeddings and writing that back into the JSON file. So I've essentially got my vector database, which is my JSON file, and I've got the embeddings for ADA 002, which is the GPT-3.5 and GPT-4, like the old embedding model, I guess. That has 1,532 dimensions. And I also wanted to test the new embedding model, which is called Text Embedding 3, and it has two modes. One is small and one is large. Now, if you look at the documentation for this, where is it gone? Okay, here we go. So the embedding models are used for similarity. And when it comes to internationalization, if we assume that we're not necessarily doing similarity with English to English, it could be English to another language or another language to another language. And probably the best benchmark we have is the Miracle benchmark, which is quite good. It's basically copies of Wikipedia pages in different languages, and then like a question. So like saying, which football team won the 2004 like tournament, and it would kind of like, and you'd ask that question in that language, and it would compare that and try and match the right paragraph in that language. So in the Miracle benchmark, the old embedding model had a score of 31. The new embedding model, the small one, is 44, and the large one is 54. So there's a significant improvement for the Miracle benchmark in particular in its sort of similarity matching, like how good it is at finding similarities in sentences for other languages. This line here is super important because when you're looking at doing RAG, if you're defaulting to text embedding ADA 002, you need to keep in mind that it is not brilliant at other languages. If you look at MTEB, which is English, the MTEB score, like the differences between ADA 002 and text embedding 3 large are not that dramatic. Like it's an improvement, but it's not necessarily like a step jump. It does also go into a bit more detail. If you look at the blog, in embedding 3 large, you can, and in the small one, you can specify the number of dimensions. And even with less dimensions, so ADA 002 is 1,532 dimensions. If you use large with less, with 1,000, you're still going to get a better recall rate for other languages. So what I've done with this sample is I'm going to calculate the embedding for the search query, and then I can pick which embedding model I want to do. So to a 50s party. So if I do the embedding for just that text, so if I run the similarity based on that text in ADA 002, I will get these results. This is in English, so let's translate that to Japanese, because I can't do that. That looks about right. Okay, so if I do that and use that on the original text and ADA 002, I will get back different results. So in the other one, I got back the denim jacket. I think it agrees is a cool thing to wear to a 50s party. But I got back different results with different similarity. Even though I typed in the same query, just in a different language. So as I think has been covered in previous sessions, a really good way to improve your search, if you're just relying on vector search, is to do some kind of query preparation. So what I've done in this sample is added a step in the code to do some query prep. So the query is the thing that I typed in. That's the query. And then I'm going to prepare that to go into before I do the embedding. So this is the prompt I was kind of working on, which is generate a full text search query for a SQL database. So what I wanted to do was, if you do a keyword search, I wanted to make sure that it's just looking at, in a full text search, you don't want to include the whole sentence. You just want to include like specific keywords. So what I asked it to do in my prompt, which I will go back into the playground, and we're going to chuck that prompt in here so I can give you a few examples.
We have a question coming in. I was creating an index through the new index wizard in Azure AI Studio. Only the 8002 model was available for me. It's on a Swedish set of documents, quite important to use a new large embedding instance.
Yeah, if you go to this page, I don't know what the shortcut link is. If anyone has it to hand, that'd be really useful. There's a table on this page, which I might not even need to zoom out to show you. You'll get the region down the left-hand side, and then the models which are available at the top. If you scroll across, you'll see the embedding models. Text embedding 8002 is available everywhere. So that's the new ones. The small one is only available in Canada and the East US at the moment. But the new large model is available in other locations, including, I thought, Sweden, Central. No. I thought, yeah, it is in Sweden Central. So I just check against this table to see. Yeah. So we're essentially going to use one prompt to do query rewriting. And because we're expecting or using other languages, and also my database, don't forget, is in English. So if I do a keyword search, so literally just a SQL-like or a full text search, it's only going to look at the text that's in the database. So like that is in English. So what it makes sense to do with RAG is to, in your initial prompt, in your query prep stage, is to tell it in the prompt, in the system prompt, if the query is not in English, always translate the query to English. This means in your keyword search, the keywords it's going to be using have already been translated into English. So if I say something to wear to a 50s party, like the preparation it's going to do will be to something to wear and 50s party. Like it's taken those and put them in a form that I can then use to do like a search. If I stuck in the Japanese example, it's done the same thing because it's the same sentence. So it's translated that into English for me and then kind of made those keywords that are easy to search. So with this app, I've basically done the query prep as a function, so that we do a chat completion. It does some examples. So we've got generate a query for a really nice winter jacket, and then like what I was expecting back is winter and jacket. If I do generate a search query for summer dress, I would expect back summer dress. So like I've given it a few examples in my prompt, and then I'm going to say, okay, generate a search query for this bit of text. So that's kind of the first step, is to do that, and you'll see that it converted my question here, like 50s party wearing some sort of clothing. That's what that means. It put that as 1950s party attire. Now, if I run the similarity on that sentence, then I get these results. If I run the similarity on the prepared keywords, I'm going to get different results. So I'm going to get slightly different ones. So if I did similarity on 1950s party attire, based on the descriptions in here, it's going to give me slightly different results in a different order. So it's saying formal events and special occasions. So I think it's overemphasized the importance of the party part, and like underemphasized like the 1950s retro aspect. But generally, it's pretty much the same. Now, in this sample, I've prepared embeddings for both models. So if I switch this to test embedding 3 large, I want you to remember that's the similarity I got back for cosine. So that's the cosine similarity for that sample with that search is 0.8 in ADA 002. And if I run that again, but on the new model, so on text embedding 3 large, which is better at dealing with other languages, it gives me this outfit, which is probably pretty cool to wear to a 50s party, and then its similarity number is drastically different. And this is something to mention, is that if you upgrade to the new one, so if you go from ADA 002 to text embedding 3 large, if you're storing the cosine similarity anywhere, or you're using it for some kind of like filtering, when you go to the new model, you're going to find these numbers are dramatically different. The actual meaning of the number, it should be a value between -1 and 1, where -1 is the most dissimilar and 1 is the most similar. Where it is on that scale actually depends on the model, and it's not something that it's kind of arbitrary, and what's important is actually the order. So this is the highest number that it found, that's the second highest, that's the third highest. So like if I look down my results and I look at this hoodie, then that's 0.23. So like in terms of what it's matched based on my query, that's a big difference between 0.35 and 0.23. Whereas if I went back and did ADA 002, like we're looking at a scale from 0.8 to again the hoodie 0.76. So what I'm saying is don't like store these numbers anywhere. If you're doing an upgrade and then compare between models, you should just stick with one model with one set of dimensions, and then just sort the similarity results. So that's kind of what you will get when you're doing prep. So my recommendations with RAG is that you would use a query prep stage, that you would look at the new model, either the small one or the large one. Don't let the word large put you off either. That has, so text embedding 3 large, I've configured this one with fewer dimensions than the ADA 002 one. So therefore the storage is actually 50% less. And also the cost per token is dramatically less than it was with the text embedding ADA 002. So this is faster, cheaper, and more efficient. And it's actually better as well, because if you look at the benchmarks, the Miracle benchmark is a massive difference with with other languages. So my recommendation is to use text embedding 3 large, and also for your query prep, to experiment in the playground with different prompts, and giving it kind of different questions with different sentences, and seeing like how it tries to turn those into keywords that you can use for similarity. And then also adding the examples in the few shot. So this is where I've said a couple of different languages. In conversation with Pamela this morning, she was suggesting that in the few shot, I could actually be more dynamic. So instead of just giving English and Japanese, I could detect the user's language and actually give a few shot in that language. So in my UI, if I change to Spanish, for example, then when I send the search, I add a parameter in my code to say, oh, the user has said that they are using Spanish. Therefore, let's give some examples to the chat completions API in Spanish. So I could go and create a whole bunch of examples where I'm going to ask for like winter jackets, or like a dress, or some jeans, or a denim jacket, whatever it is. And I could write those in Spanish, and I can just switch out which examples I'm using in my query prep stage. I think that would improve your recall rate quite well. And then the other thing I want to mention is that this is not just about the language element as well. This is how I can write an app where I can do or search in one language, it's searching a database that's in a different language. That's really cool. But if you look at the data that it put in my database, I think it kind of summarizes another consideration, which is that I asked it to generate some clothing and stuff like that. This is all this is all Western clothing. I never asked it to do that. It just assumed. So if you're using this for, like, if you're using GPT-4 like to create sample data or examples or names or addresses or like anything like that, you need to kind of assume that it's got an sort of a strong training focus and a bit of an over bias towards like Western names, Western clothes, and Western culture. So like if you're using it to do an app and build an app and then demoing it to people, you need to keep that consideration, because it's given me jeans and hoodies and t-shirts, and this sort of bizarre looking golden dress. So like I never asked it to, I just said a clothing store. I was never specific. There are lots of different types of clothes. And like, so when you're using it to do training data, you need to also kind of, if you want it to be like diverse about the stuff that it's giving you, you need to tell it to do that, because it will not do that by default. The library, if you're doing especially example data, like the library that I always recommend is this one. This is not an AI tool. This is a fake data generator for Python. This is great if you're testing applications for like other languages, other locales, stuff like that, because when you're making fake data, you can actually specify the locale. So you can say, give me 1,000 names for like Brazilian Portuguese, and you can ask for like fake addresses or fake phone numbers, and it will give you those addresses in that specific locale, so in that language and in that locale. So this is Mimesis, I think, is a lot more structured if you're using it for fake data. I think if you're using GPT for fake data, it will overemphasize English and it will overemphasize like Western culture. So just keep that in mind when you're building it for those things. Cool. We've covered quite a lot. So if anyone has any questions, pop it in the chat. Or if any of the moderators have got questions for me, then please ask away.
Pamela's also just pointing out that Faker, it's great as well. So yeah, lots of good tools out there for internationalization and diversity and inclusion, because the web, it's for all of us, which is good. I guess this all is like on the topic of like responsible AI as well, because like we do have like a moral responsibility to like make sure that all of our tools and stuff that we are using are like accessible and inclusive and like relevant to like the diverse audience that like the internet serves. So I think this has been a really cool talk. Pamela is asking, what about getting RAG apps to respond in particular languages?
Yeah. So, have you tried to modify the system prompt to always reply in Japanese? Yes, and it doesn't do that very reliably. So I've tried with a few different models asking it to always respond in Japanese. And then when you ask it or talk to it in Japanese, it flips back to English sometimes. I think probably like tweaking the parameters to a point where it doesn't get too creative, or giving it examples of the kind of what you would expect back. You're going to get it more reliably to stick with the language that you've asked for. The other thing is that the search results, like I'm searching in Japanese, it's giving me back results in English. Like this is another consideration, is that I could get I could do like another round in the LLM to like translate that back to the target language. That's pretty inefficient because this data is not changing every time someone asks a question or does a search. So what I'd recommend instead is to write a script to basically go through the database and do all the translations, or to use like Crowdin or like a proper translation management tool to do like the descriptions in different locales and different languages. Yeah, so you could add a translation step for the LLM, but like you need to consider the performance cost and the monetary cost of that as well, because you're going to be giving it a lot of data.
So if you were doing something that was more of like an ad hoc response, like if you had like a chat bot that could respond in multiple languages, you might consider that like possible like two-phase approach, like possibly using like an agents, like an AI agents combination, like strategy.
Yeah. I think if you like with this one, we're converting in the query prep stage, we're converting it to English first. We're translating it to English first, because the similarity with English is going to be more effective. And then it's the same when you've got like a long prompt or a set of instructions. It's going to be more more accurate and more responsive if all of that stuff is in English. So like translating in and then translating back out again will probably give you better results than just telling the whole thing. Like if you gave it a system prompt in Japanese and you gave it information in Japanese and then you expected results in Japanese, I would strongly expect that the performance of that to be less than if you translated in to English, kept the system like prompt and the configuration in English, and then translated back out into a target language.
With our 1 minute left, I have one final question. Can you introduce yourself? Because I think we kind of glossed over that at the part. Who are you, Anthony?
All right. Yeah, so I'm one of the Python advocates, focused a lot on Python performance, and work on like web apps and security and stuff like that. And I've been dabbling with RAG and with AI, in particular on like Chinese, Japanese, and Korean, and researching like how the AI works with those platforms. So yeah, that's me.
Amazing. And I'm a senior cloud advocate on Anthony's team, because he is our lovely leader of the Python advocacy team here at Microsoft. I think we're out of time though.
Yeah. All right. Yeah. Thanks for joining us today, everybody. I hope there's some useful information here. We'll add some links to the blog post with samples for text splitting, recursive text splitting by tokens, the fake data tool, the sample we've got here for similarity, and some comments around the prompt translating in and out, and then also this like super important availability chart and descriptions of the embedding models and the benchmarks and stuff as well is all good reading.
If you have enjoyed this, or you're not enjoyed it, I guess, do our survey as well, which has been dropped in the chat. And if you do continue to have questions that you haven't got answered today, or they're just coming to you now, there is the GitHub issues that you can join the conversation there and get your questions answered after this session as well.
Thank you very
Hey
much.
everyone, hope you enjoyed today's session.
If you aren't registered yet for RagHack, you can register now at aka.ms/raghack/register, and you can introduce yourself on our forum. You can start hacking either by looking at one of our code samples or just starting from scratch. If you have any questions along the way, feel free to post them in our GitHub discussion forum, and you can also attend live office hours in our Discord. Once your project is ready, make sure to submit it before September 16th at 11:59 p.m. PT to be eligible for our cash prizes. And of course, make sure to join our upcoming live streams to learn more about RAG. Thanks for joining.
Thank you all for joining. Thank you to our speakers. To learn more about this series, watch past episodes, and register for future sessions, you can follow the link at the bottom of the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link also on the screen or in the chat. Today's event code is 23415, and we'll see you at the next one.